little bit of history to begin with again. The first major steel structure in the UK was the Forth Bridge, completed in the 1890s and now a World Heritage Site. Neither timber nor stone were suitable structural materials for tall buildings, therefore steel facilitated the development of the skyscraper. It very quickly became the material of choice for large structures and tall buildings, and is most commonly used for traditional construction frames, which are not covered by this module. This part of the module looks at the characteristics, performance criteria and systems fabricated from hot-rolled steel, HRS, light gauge steel, LGS. HRS is the primary structural material for one type of 3D volumetric module, usually comprising either square or rectangular hollow section posts with horizontal perimeter floor and ceiling channel sections. This creates a point-loaded, story-height chassis structure with the vertical transfer of loads via corner and, where included, intermediate posts. The HRS chassis of a module must be fire-protected in the same way as a conventional steel structure would be in any other building or development. Depending on the type of accommodation, the chassis is fitted out with interior and exterior finishes, fixtures, fittings and building services. Closed residential modules can be fully fitted out in the factory ready to plug into the site infrastructure. Module dimensions are constrained by the weight and transport logistics of the UK road network, including the bridge weight and height restriction, 4.8 metres on motorways, and road widths. A typically two-bedroom home will fit into two modules, which can be assembled side by side for an apartment or vertically stacked for houses, maisonettes and duplex apartments. Depending on the star rating, it is possible to fit 2 hotel bedrooms into one module. The world's tallest residential development assembled from HRS steel volumetric units at 40 stories high is George Street in Croydon. Large open-plan spaces can be formed with open-sided volumetric units, which require significantly more finishing works on site. This is usually described as a sectional building, with interior and exterior walls factory installed wherever possible. The main advantages of this approach are less disruption and reduced site works duration, which are often client requirements. HRS is also used as the frame of non-structural assemblies and components, for example bathroom pods, utility cupboards for residential developments, prefabricated plant rooms and vertical and horizontal building services modules. With some forethought and careful planning, the frames of non-structural assemblies can be incorporated as the primary structure of a building. LGS is the main alternative to HRS as the primary structure material for volumetric units, comprising thin gauge 1.2 to 3.2 mm thick, lipped C-section galvanized cold-rolled steel. The result is a line-loaded structural chassis with even distribution of vertical loads along the outer edges of the module. This vertical load transfer is a constraint on the flexibility of LGS modules along with a height limitation of approximately 60 metres compared to HRS. LGS modules, as an alternative to HRS, are generally used for projects where the ground conditions are poor and the interior layout of the building is cellular and repeated vertically with only a few large open spaces. The exceptions to this rule are developments of more than 20 stories where HRS is required. LGS is also used for the 3D assemblies and sub-assemblies, including bathroom pods and utility cupboards for residential developments. LGS is used as the primary structure for open and closed panels and for structural components such as roof trusses in a similar way to sawn timber. Closed panels can be fabricated with interior and exterior finishes, bonded insulation to prevent cold bridging, windows, doors and some MEP components factory installed. Structural characteristics, height and flexibility constraints are exactly the same as LGS modules. The material is relatively lightweight, making open panels easy to handle manually, which facilitates safe, fast and cost-effective construction.
With EOS being a founder member of the Light Steel Frame Association, events like this where there's open knowledge and knowledge sharing I think is excellent. There's a groundswell of interest in light steel frame, and not enough people get to see it in application. But there's no substitute for coming to site and seeing it. And I commend EOS for organising events of this nature and engaging with people and being as open and transparent in your process as you can.
The key thing for us is actually having the opportunity to discuss with other main contractors, architects and consultants about the process, and actually physically let them get some hands-on experience of the light steel structure, but also see how another main contractor has made it work for them and ultimately made it work for their customer.
A number of the other founder members should follow suit with this and directly engage more with architects, engineers, specifiers, contractors.
We really are pushing for certainty in the market, but actually having the opportunity to explain about the fire testing that we carried out and to physically show how that would work on the building as it's being assembled has worked very well.
What stands out is the way in which you've integrated a very complex building structure here into a tight site with a lot of hot and cold rolled, so effectively a hybrid structure. My biggest take is that most of the contractors that have been on the site tour today are really very surprised at how slick that process is and how really well that integration appears in the flesh.
As an off-site industry, we need a voice. We are a big industry, there are a number of players, and now for light steel frames we actually have an opportunity to be louder in the marketplace, and to have that opportunity I think will work very well.
Light gauge steel is more accurate, easier and faster to work with compared to hot rolled steel, but it is not suitable for developments of more than 20 stories or developments with large open plan spaces. Point-loaded HRS modules are relatively easy to stack and connect, but they do not achieve high-rise lateral stability on their own and must be augmented with an in-situ concrete structural core. Fire compliance and sound attenuation must be carefully considered where LGS is the primary structure.